Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about single board computer versus low power PC. So let's dive deep into it. So what exactly happened? Well, you have to understand initial success of Raspberry Pi in 2012. Remember that year when world used to supposed to go boom? In that year, flooded the whole market with low power ARM-based single board computer. Low power meaning it was supposed to run on such a low power that you can drive it with a power bank or small wall watts. Very low power, as in like less than 25 watts. Nowadays, our smartphone chargers have more power. Basically very low power, and single board computer meaning one credit card size, and that's it. The end. Like it has everything that it needs to act like a proper computer. Now, this happened a decade ago. So over the decade, compute power increased exponentially, meaning if you compare Raspberry Pi original to Raspberry Pi 5, the compute horsepower is exponentially different. So that happened. And because of the use and proliferation, softwares got better because here's the deal. Hardware on its own is meaningless. Unless you have a good software and good marriage between hardware and software, output is hulululu, means nothing. But Raspberry Pi, the Pi Foundation does know one thing very well. It's like, hey, let's make sure the software is well documented. So it allows a few users to get in. Then refine it. Then more people get into because of the community feedback, and then more people start to use. So it's a very well-crafted, self-fulfilling prophecy, and they are very good at it. That's why the software experience on Pi is exponentially better compared to every other alternative options. And be mindful, big companies tried it. There was a time where Asus tried it, but it did not last very long because many companies try to make this, and it's easy to make this. It's just hard to software support it. So better software happened, and PC-like experience started to become a thing. So nowadays you can buy a basically Pi keyboard and just use it like a computer, low grade one, but a computer. You can do that. However, when this puppy came out, it was $35 in 2012. So it was cheap, not very expensive. However, Raspberry Pi 5 now, it's bonkersly expensive. It's not expensive, it's bonkersly expensive. And God help you if you tried to buy it when chip shortage was happening. Oh my god, the price on these puppies were reaching smartphone level prices. So that era of low cost single board computer, that disappeared. That like overnight after pandemic never came back. And even the third parties manufacturers that are making like something similar to this, even their prices are jumping up. So price has jumped up exponentially. So this was the start, but price has changed. Now, in the same time, last 10 years, PC industry has not been, sitting idly by. x86 is still a dominant PC workspace tool. What does that mean? That simply means there is a very good chance if you are actually doing some crunching work, like let's say when I was a 3D game artist, what was the probability of all our computers being x86? All of them. What is the probability right now? All of them. So that's the same thing. Like you can go to any office. What is the likelihood of you just getting apples versus what is the likelihood of getting x86? x86, most of the time you will get x86. So offices, business, they still rely on it. So fundamentally there is a large amount of backbone, large amount of support. x86 is still alive, still well. Yeah, we keep getting news that ARM is better or Apple left x86, and that is true, that fundamentally speaking ARM is doing quite well in terms of energy efficiency. However, it does not mean x86 is lying still. So they are also working their ass off. Why? Because corporate market, they love low power computers because they know for a fact that they have a department like back end developers or some heavy people that require some heavy computers like game artist and all that. But they know for a fact the majority people do not need that. Like if you have receptionists, they do not need i9 900K or something like that. They do not need that. They're like bro, simple computer. Most of the time, even in a very high compute environment, you may have a central server that is doing the heavy lifting, and you just want what we call thin clients. It's just a client system for you. You do not want very high power on every single table. And given the fact that you are paying electric bill for them and air conditioning bill for them, you would be inclined to search for tools that are very low power, and that gave birth to these puppies. These are full-fledged computer, and be mindful, some people may still be using low power computer compared to these things, and these are flooding the market as of now. Why? Corporates generally have a cycle where they they buy something, they keep using it for a very long amount of time, generally 5 years, and then they just flush it and get a whole new set. Now again, it's not necessary it's 5 years. Sometimes it happens very quickly, sometimes they may stretch it to 7 years, but generally that's the cycle where they're they buy it, they forget about it, and then the clock reminds them, it's like, okay, now it's time to flush. again. So right now market is being flooded, and even in India we can get very high grades low power computers, and you can see they can come up to 6th gen i5, or like some scenarios, if you are very lucky, you can even touch 7th gen processors. And these things do consume less power. It's not your old computer of like starting power is 100 watts. They can drop down to 20 watts even, and yes, they can run application at 20 watts. So because they are practically overgrown laptop. So fundamentally, low power PCs were the core wish, and companies worked their ass off. HP, Dell, Lenovo, AMD, Intel, all of them got together and they worked their ass off to make sure low power PC is possible. And it became possible. And improvements of Intel, while it's overshadowed by AMD's improvement, but both of them have made significant improvement. AMD went on a whole different level. We have to wait another flush cycle when these sort of system starts to use AMD. I would expect that to happen by 2030 when we start to get flooding that has AMD, because AMD has made some genuinely awesome thing, because this is the first time you can have a handheld gaming device that is x86 and full-fledged Windows level graphics and processing, and power draw is 15 watts. That's like mind boggles. Like a full-fledged PC level experience on handheld for 1 hour on battery power. It was unheard of, unimaginable. Now it's here. So fundamentally, improvements have been made in x86. It's not like, oh, ARM is everything. x86 is still fighting on. So what does this mean? This simply means you can get a very powerful small PC for cheap. And be mindful, these are old refurbished ones. Does that mean they are crappy? No, they are still, many of them do come with warranty, some with 2 years of warranty. So they are brand new, practically speaking. And many companies are making new devices that are again cheap. New devices that are cheap, and they have very low power draw, meaning this puppy will be consuming 16 watts of power, this puppy will be consuming 20 watts of power. You see? So power gap is no longer the old days of like, a single board computer is like 10-20 watts and this puppy is like hundreds of watt. It's not that anymore. It's like very close. So you can do that. And real world power draw with some optimization people have achieved. Again, these things were designed by that. So they are fundamentally made in such a way that you can go in very low power state. So if you are just doing something that is like collecting data from a lot of other services or technologies, you can just keep running them in the background. So x86 also made some improvement. This also went upgraded from 2012's offering. This also went down in terms of power size and in terms of physical size into there. And right now you can buy, if you have money, you can buy a single board computer that is same size as Raspberry Pi, but it's super expensive. It's like $450 or something. But that's a full-fledged Vega GPU and CPU. AMD offerings is there. But super expensive. But again, if you need a credit card size, full-fledged PC, you can get that. So x86 is also making some serious progress. Now here comes the paradox. Right now you have to, the more a single board computer tries to be like a PC, for example, this is an Orange Pi Zero. I received this for review and I've already made a review on this. This is a very low power device. Can I run this as a basic device? No. You have to understand, back in the days, this was like the compute horsepower in this puppy was main compute for majority of people. My first computer only had 4 gigs of RAM. Many people started computation with 512 megabytes of RAM. This is 1 gigabyte. Why can't I use it? Today's web environment is very heavy. Like the web pages itself. Back in the days, we had netbooks. You never hear them anymore, right? It's very unlikely that you have heard, oh, netbooks are still a thing. Why they are not a thing? That's the reason. The website itself is the heaviest part, and nowadays many people can just do their whole job just on a good web browser. But again, web browser itself is now heavy, web pages are heavy. YouTube went, because I've been using YouTube for 15 years, idiotically heavy. So the solution becomes make them more powerful. The more they try to make it more powerful, the worse their price to performance ratio gets. And laptop basically vendors, PC vendors have the advantage that they already know how to make a laptop. Imagine they're just making a laptop with a bit more freedom, bit more space freedom, and instead of soldering a CPU, they are just putting a socket there. Nothing else, it's just a laptop. It's very easy for them, but from a single board computer, it's a hell of a hassle, because modern operating system, even the Linux operating system that these puppies are running, it's becoming so heavy that micro SD card is unable to cope with it. Back in the days of 2012, nobody was complaining about it, but now everybody is like, dude, SD card just keeps burning out. Why? Because we have pushed beyond it. We are trying to make it into a full PC. So you have to buy a Raspberry Pi hats that has like, NVMe, or like, use this. It has a back slot that has supports full NVMe SSD. Now, problem with that is like, that's cool and all, but it increases the price. This puppy that I have in Indian market costs same as this puppy, and I do not even have to compare them. Like, for a fact, yeah, it's a bit older, like it's not 10th gen. It's old, I think, if I'm not mistaken, 6th gen or 7th gen. Optiplex 3060. So not very current gen or something, but still will have more horsepower than this puppy, and this is more expensive. Oh, and this has more RAM, and I can increase the RAM. So it creates a very serious paradox, and you need PC-like systems. And this is why you have to understand that when people originally getting their Raspberry Pis, there was a complete different ecosystem. Now it's a different ecosystem. So now everybody's like, dude, can you put a NVMe SSDs to it? You need that. Again, real-time clock. That's still missing. I'm genuinely shocked how many single board computers do not have a very dedicated place. Just put a coin cell there. It's not there. It's frustrating. And again, look at a computer system. They knew from day one, that shall have a clock battery. And USB 3.0, for example, my aim with this is that I'm gonna travel. I do not have a laptop, so whenever I do photography, I'll take basically my camera's card, dump it into here, plug it here, and dump it into the basically Western Digital 1 terabyte NVMe SSD. I want to dump all the file here. Now this is a USB 3.0. It should be able to do. Now that's one use case. Other scenarios also, because data transfer is such a important part of computer use, you need 3.0. Now be mindful, 3.0 translates to around 5 Gbps. Computers like this, they can go higher than that. They can go around 10 Gbps. If you buy a really modern ones that is being sold to corporations right now, they are a bit expensive, but you can buy them. They're still low power. Actually, they are even lower power than the old ones. They can give you 20 Gbps ports. So you can dump bonkers amount of data using USB. And you're like, do we have storage devices? Yeah, NVMe based SSDs are available in market for cheap right now, and you can make them yourself. And that does allow you to dump data at 20 Gbps. You cannot do that in any single board computer. Like, think of this, like, I'm not planning something bonkers where it's like, oh, I'm just gonna like do this and that. No, all I want this to act as a computer where I can just like, hey, I go to a hotel generally have a HDMI, plug it in, plug the power in, I'm just like use keyboard mouse, dump all my camera footage. That should not be very hard. It is very hard on this sort of devices, because SD, technically even this should be able to do that, but it only has USB 2.0. If I try to dump a 256 GB card using USB 2.0, yeah, it might even take whole night or maybe even longer than that. So there are some serious issue. We are reaching some breaking point where SD card is no longer a good enough storage medium. And web itself is getting heavy. That is the most critical aspect you have to understand. Web pages that are being built right now, they are heavy, they are heavy AF. So they need a lot of oomph just to run it. That's why we do not see netbooks coming back anymore. It's like even Chromebooks, they are very computationally powerful because they have to be. So this is the paradox where every manufacturer who is making these sort of things are stuck, where it's like, okay, I want to put this and that and all this. It's awesome, but it's like, it's very expensive. And back in the days, that was not an issue until these started to come in the market. So for most people who just want low power computer or want to do something computationally heavy, they're like, just buy this. And power draw is no longer where it's like, oh, this will consume, let's say 20 watts and this puppy will consume hundreds of watts. That's not there anymore. So what do you do? Now, of course, there are still some edge cases, but they are only there for people who need the development horsepower. Basically, they are developing a product. Then this becomes a basic dev vote. So you have to know, there is a serious paradox that every single board computer is going through right now, and you must have experienced it. So let's come to the user end of it. Now, single board computers are not user friendly. I can take a Windows laptop, give it to people. Most people will figure out what to do with it. I can do the same with basically a Windows PC. If I try to do that with this, yeah, it's not working. Even Raspberry Pi, it's much better compared to how it was in the day one, but still nowhere near where it's just user friendly. It's developer friendly, not user friendly. So fundamentally, you have to struggle with the fact that there is no master OS. How the heck HP, Dell, Lenovo and all other brands, they are making computer? Because there is one OS. They make sure that it works with Windows. Windows makes sure that it works with Intel and AMD, and all of them working together that allows us to make sure that I can buy a card reader and it can work at full speed, because this card reader, it's a USB 3.0, so it should in principle can go up to 500 Mbps. It's suppose UHS 2, my card that I'm using in the camera is UHS 2.0. When I'm running it in my Windows PC, I am getting around, let's say, 150 to 200 Mbps of read data speed. That's good, stable, awesome. In this, even in USB 3.0, it has ports, but does not have driver for the card reader. It barely gives me 80. Now 80 is much more than USB 2.0. So it is working in USB 3.0, but does not get the full power. So that's a very serious issue. Why? Because there is no one OS. There is no single board computer OS. And that's a big issue. That simply means all the periphery developers, people who are developing mouse, people who are developing printers, card readers, things of this nature, accessories, tools, they reach up a point where it's like they develop their tools for Windows most of the time, sometimes for Apple, rarely, once in a while, they also develop it for Linux. So that creates a very serious issue. And Linux, which Linux? That's another hassle. It's like which exact Linux it's there. So many options makes it hard, and driver support is almost zero. For example, this is Orange Pi, and you may think this is a good thing where you have Orange Pi OS OH, Open WRT. That's for if you want to use this as a router, which would be a really good use case for this. And then you have Open Orange Pi OS Arch, Orange Pi OS Droid, which is Android variant of it. I'm not sure which one has better USB 3 drivers. Ubuntu image is there, Debian image is there, Android image is there, and you have Android source code and Linux source code. And of course, if you are a developer like Jeff Gerling and you can compile Linux kernel, go YOLO on it. But again, you are a developer, not a user. So these two ecosystems do not match very well with this environment. So what does this mean, like end use? What does it mean? It simply means this is one of those things where it's single use stuff. For example, this Orange Pi 03. Do I have a plan for it? Absolutely. My plan is very simple, nothing fancy. It's very simple. I want to plug this puppy to my Ender 3 and use it as a Clipper host. That's what I want to do with it. So it's perfect for those sort of where you want to make it into a router. Like this has enough horsepower and it has 2.5 Gbps in and out, so it can actually handle a large network. So let's say you are running a hotel, and biggest mistake many hotel people do, they buy the gear, all of the gear, and they buy the cheapest gear possible, but they give good coverage. That's awesome. Okay, so they have access point in every basically hallway. They have like 2-3 every if it's a long hallway, they have 2-3, everything's fine. But router is very low power. So once you have a lot of mobile phones trying to access it, a router is like, I cannot do this. And because it's not properly balanced, it reaches a point where it's like the user that connects first gets a lot of speed. Awesome. Because again, they paid for a good fiber connection, and user that connects afterward is like, lol. I saw this was a difference between PG, not PG as in guest house I was staying versus a 5-star hotel I was staying in. In that 5-star hotel, everybody was getting 10 Mbps, but benefit, everybody was getting 10 Mbps. They were not like, oh, somebody who connected to the network first and it's like, oh, I'm getting like 100 Mbps. Everybody else is like, why is buffering? So you have to do that, and that requires a lot of compute power. Now, of course, you can buy ubiquitous gears, professional tools for it, but yeah, those are expensive. So in those sort of scenarios, this sort of device is a godsend because it has enough compute where it can handle very large client base and still throttle connection accordingly, and you can do a lot of filtering. So you can reduce a lot of wastage. Basically, you can block a lot of ad. That will reduce your ping times exponentially. So router is a bit, and again, you have operating system for that also, OpenWRT, and then you have smart home. Many people are now being frustrated by the fact that every company is making Hulu and all of them have security leaks. Might as well just have everything in home. You need one computer for that. Good for device for that. And then you have retro emulator. This I do not get, but I understand it. Like again, I used to play NES, but again, NES never actually came to India properly. It was video games. We used to call it TV video games. Clone of it, NES, and that was in like early 2000s, so it was late. So many people still love that for some reason, and they want to play for it. Again, go YOLO on it, and you can, in those sort of environments, single board computer shines. But if you want to use it as a computer, it does not shine as much as you would think, because be mindful, this is designed for developer kind of people, not user, not you and me. So I would search wisdom here. So wisdom is you have to fundamentally understand the golden age of low cost single board computer is gone. That's past, because if Raspberry Pi starts to increase the price, everybody else will already do that. And be mindful, this puppy is expensive. In India, it's very expensive. So it's very expensive. And they are stuck in a limbo of basically they are going back to the old roots of expensive development board. That's how they started. The single board computer was not a new concept. It was always there as early as 1990s. It was there for industrial clients. It was always built things for like ARM processors and all that jazz. It was a thing. What Raspberry Pi did, they made a software packet for it, and they made a very low cost variant of it for general consumer use. A general consumer as in like a teaching tool where you can learn what the heck is a computer. They wanted to pass the magic of a computer. It's like computer is not magic. It's like, it's a thing that works. So that was the starting point, but we are reaching again to that point where it's like so expensive, where it's like, it's going back to that old back. Basically, it was a technological revolution that got us here, and then it's going back. It's like how smartphone was like low cost computer. Now smartphone prices are like, yeah, my car is cheaper. So I'm not joking. Second-hand cars and the current flagship, the prices are too close. So it's going back to that. And it's great for tinkering projects. If you are that kind of individual, I'm going to tinker with it, I'm going to develop something, that's awesome. That's awesome. For those sort of people, shut up, take money. Like if you want to run a large cluster server computer system, where else are you going to find other options? Heck, nowadays actually you can do that, because especially if you need something that requires large RAM, let's say some compute modules that requires let's say 16 gigabytes of RAM. Yeah, 16 gigabytes of Raspberry Pi 5 would be very expensive. So that's an issue. Some tinkering projects, if you're running a cluster computer, you want to learn how to manage cluster computers, these are awesome. Study tools, these are awesome. There is no discussion about it. It's fundamentally awesome. However, you have to be very mindful about your own needs. Meaning, nowadays, I would not recommend anyone to just buy a single board computer. I could recommend them to just buy a low power PC and just figure things out. Figure out Dockers, figure out how to make NAS, and figure those things out. Those things can be done. But trying to force that basically media center and all that, and be mindful, media center consume a lot of power. 4K HDR content is heavy, so you may find, hey, just a PC. Hey, I can just plonk a big ass SSD into it. That's easier, and I can dump a lot of media file from using an USB 3.0, proper USB 3.0. That's far more desirable. So you have to be very mindful of your use cases. Meaning tinkering. If you know that's what you're gonna do, go YOLO on it. If you I want to use this to learn it, because be mindful, I have ISP users, fiber optic service provider. They must have built that damn box. That means somebody would have worked with something like this to actually make the damn thing. So there's people for those sort of learning tools is still awesome. And yeah, you have to understand, this is a bitter pill for us, is that yes, single board computers are expensive in India. This puppy is 17,000 rupees. Whew, it's expensive. And that's the lowest price I got, which if I'm not mistaken, that's like a sale for some reason for 20% off. At full price, this is painful. That's like, I would not recommend this to most people. And they sent to me this. I'm like, I did ask them, like, do you have a distributor in India or not? So it is expensive. It is what it is. We can't do anything about it. So only solution is like, be mindful before you buy it. So yeah, you can buy Raspberry keyboard and Orange Pi keyboard, and these are good tools for getting your kids involved with a more compute side of things, and more like, okay, Linux is a thing, how kernel works, how those things work. That's awesome for that. But you have to be very ready for it. It's like, and I do not like the Pi because it just uses micro HDMI. It's like, why? You have a big board. I get it. Like for small board, I get it. But for a big board, they did not update it. This is one good thing about Orange Pi. They updated it. It's like, hey, full size HDMI. So you do require a bit of wisdom nowadays. It's not like just a project that you can buy. And like, what if I need that IO pins with my computer? Try ESP32. You will be pleasantly surprised. Heck, I built a whole open source system where I can use Arduino, run a sketch on that, and collect data using CSV, data logger. So fundamentally speaking, be very mindful looking into single board computer. That golden period is gone. So this was my presentation on basically single board computer versus low power computers. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.